Perfect. So I'm going to start with a short presentation, just give it some context, and then we'll go into a live demo. So today I'm talking about data quality and why it's especially important in the Medallion architecture. So just a little bit of background. So I'm currently working for Flash Food, and what we do is we're a marketplace that connects surplus food to buyers. So we're offering food at a discount price, and we're keeping it out of the landfill at the same time. So really, it kind of has the two pieces to it. A bit more on me. I've worked Flash Food now. Previously, worked in IoT and manufacturing, both in with the Databricks platform, and been using Delta for some time now. So we've probably already all seen this this graph, and it looks really nice and simple. And it's just bronze, silver, gold. Then you suddenly have it in where you want it. But in the real world, it gets a bit more messy and a bit more complicated, because usually the sources aren't just one-to-one.
Hey.
So in practice there, it's going to look a bit more like this. So you're going to have all your different sources, your data lake, databases, your streams, or your external APIs. You're going to bring them in raw just somewhere as almost a landing zone, maybe apply some schema to it in bronze, just so you know what you're working with. But then you're going to kind of bring it into silver, and these could be more ad hoc analytics tables, but they're going to serve more of a particular use case. So you're bringing things together, you're taking out the fields you no longer need, and you're really making it presentable to an analyst or a data scientist. And then the final ones is going to be your gold. So that's going to be maybe your reporting tables, so nice wide ones for your Tableau or your Power BI, or you're going to have like a feature store that's going to run into some ML model on the end. So that looks all nice. But the problem that comes out of that is now you have all these connections from upstream sources downstream, and you're trying to figure out, okay, somebody has said there's an issue here. How do you actually find out where that issue happened? And how can you be comfortable telling everybody that, oh, here's the issue, let me fix that right away, or hey, there's no issue, it's supposed to look like that. So that's kind of why I looked into an automated testing framework that you can at least have a sense on these tables and just really good idea of if there's any problems behind the scenes. So some motivators for this is going to be know of the issue before the end user, be able to debug where the source of the issue is happening. Don't regress as modifications are made. So maybe somebody goes in and switches it to an inner join, and suddenly half your data is gone, or they're dropping nulls, but they did do a subset on which nulls they're dropping, so suddenly it's not as expected. And you're really trying to find those silent errors that you're not going to catch in your typical code. So a bit more of a demo into how we've been doing this is we're going to go through Databricks Connect, and this is going to give us the Pytest environment just as you would unit testing. And the nice thing about this is you're going to have the ability to run these right from your IDE, and you're going to be able to connect to your prod environments. So if we go into one of these silver, and we can look at temperature test. So the nice thing is we can actually go in and talk to our prod data. So in a more production non-demo environment, you might have like a read-only connector, read-only cluster. So that way you could give QA or somebody else access to write just even SQL queries, expectations on what they want that table to look like. So in this sense, we're going to have a different file that's going to kind of manage the quality of each table. So if we look in here, we're going to have a file for each of our Delta tables that exist. And these are going to be responsible for keeping track. So like a couple examples I've previously done just to keep it in context is, for instance, we're bringing over a change feed from MongoDB database. And you want to make sure the IDs match on your Mongo and your Delta, and you're not missing records or expiring bad records. So you can actually, in those test files, query your Mongo, query your Delta, and do an accept all. So then the nice thing too about using Pytest is you get kind of the features out of it. So if we go into our data lake, we have the setup. So same as our test structure, and it's going to be the same as our data structure in our Delta lake. So if we go in here, we can actually see our bronze tables. So we have flights, weather, and then our different tables underneath there. Flights, just went to, but the same thing for the test. So what this is going to do is in this conf test file here, it's going to give it some logic to add any HTML output of the test that's run, and it's going to tell it to copy it into an object store just so it's accessible to everybody. So the result of this is you end up having these tests, and it's going to mock the structure of your test file, which should mock the Delta Lake. So if we go into one of these, it's actually going to output a test each time it runs. So the most recent one, we can actually go see, hey, how is the quality of that data? And in a second, I'll show you how it's actually scheduled and how you would be alerted on if these tests failed. So here we're going to see the result of that test running. So here we're going to say, if we hide this, it's running 2 tests. It's checking is data recent and is data in range. So if we open up this failed test, we can see the test that was running and then some standard output that's just kind of printed out to the command line there. So here it's going to say, hey, the most recent 10 records are this. So pretty old, and these are actually off these Databricks sample data sets. So they're not up to date, and my test is going to fail because of that. So it's going to say it's checking records as of yesterday, and that's going to fail it because they don't exist. And other things, you can really extend these. So it's going to be business specific logic. So for instance, one time I had a gaps and islands solution. So trying to find the ones and the zeros of different dimensions. So you're checking, okay, are they alternating each time because you're updating incrementally? Is there anything weird in the data, or does it match business value? So the final thing then is I wanted to be able to schedule these Pytests to run just as I would my normal jobs. So using this function here, I'm able to pass in a table path, and it's going to call pytest.main, and it's going to run the test path that's passed in. And then after this, we're going to package this up as a wheel and then copy some things to the Databricks portal. So here we can see just this project packaged up as a wheel, and then also just the test file, raw test files. So in here we can go in and see that I actually can call these from something like an Azure Data Factory, or really whatever orchestration tool you have. And you can click debug, or I have them scheduled, for instance, every 3 hours in my actual more production environments. But you can see exactly, okay, gold predict delays was wrong, but it's actually getting caused by the silver weather temperatures that doesn't have recent data. And we can look at and see exactly how these are going to be called. So we have our main class that's going to call into our wheel, given this job, and it's going to pass in this parameter. So it's going to pass that test. You could also extend it to just call them all in one test run, in one job, just loop through the paths and call them. But I found this case gave a nice way to see exactly where the failures were occurring. Yeah, that actually covers it there.
Awesome. So do we have any questions? Also, speakers are allowed to ask questions to each other. All right, cool. I don't see any in the Zoom chat. Just checking the platform chat. All right, looks like we're all set. Well, I linked to all of the speakers' contact details. So feel free to reach out to them on LinkedIn. And thank you so much for joining the community sessions, the lightning talks. Thank you to all of our speakers. Thank you, Carter. Thank you, Marin, Michael. And great to have you all. And I think we're just about ready to start the last keynote here for Summit. So hope you all are enjoyed so far. Sorry, did you want to say, Michael?
I just want to say thanks everyone for watching and enjoy the last keynote. And I hope you had a good time at the Summit as well.
Awesome. Well, with that, I'll let everyone go and take care. Thanks so much.
Thank you.
Bye.
Bye-bye.